8.1, understanding functions. So this is a pretty big, important unit. It's not really long, but it's a great unit, and you're going to see a lot of it next year when you get to algebra. So what is the definition of a function? For every, and we're going to apply this so it will start to make sense, okay? For every x, there exists one and only one y. Okay, whoops. Did I write? Yeah, I wrote that right. One and only one y. In other words, we could also say it this way. Each input has a single output. And once we look at the examples, these definitions will start to make sense. So it says determine whether each relation is a function. So a relation is just, in this case, a group of points. So now let's see, is it specifically a function? So the relation is like the umbrella, okay? And then specifically, could it be a function, or maybe it's not a function, okay? So that relation is sort of the big umbrella, and then what's under it, functions or not functions. So we have this set of points. My first point, 2, 3, 3, 0, 5, 2, -1, -2, and 4, 1. And what are we looking for? It says for every x, there exists one and only one y. Or, think about it this way, each input has a single output. So my inputs are my x's, and my outputs are my y's. So I'm going to determine if this is a function. So what do I need to look at? I really need to focus in on my inputs. I have a 2, I have a 3, I have a 5, I have a -1, and I have a 4. So none of my inputs have been repeated. None of them have been repeated, so therefore it tells me, so when I look to see, I don't have any x's that repeat themselves. So each input has its own output. I don't have an x that goes to the same x that goes to a different y. The x's are a little fussy like that. So we'd say, yes, it is a function because each x has its own y. So now, what if I have, so that's just a list of numbers, okay? That's a nice list. This right here is called a mapping, but it represents the same thing, okay? It's just another sort of graphic organizer. So if I were to think about this, this would be 3 matches up with 0. So if I wanted to make a list of it, 4 matches up with -6, -3 matches up with 10, and -8 matches up with 10. So when I look back through it, does each input have a single output? Yeah. So 3 gets 0, and 4 gets -6, and -3 gets 10, and -8 gets 10, and then you start to question yourself and you say, okay, well 10, that output has 2 different inputs. That's okay. That's okay, because go back to our definition. For every x, there exists one and only one y. So the x's, okay, can have the same y's. It's just not the other way around. So in other words, think about it this way. You can't have any x repeaters. No x repeaters. So this one is, yes, it is a function every x has its own y. Okay? And I'll put in parentheses, no x repeats. Okay? So let's look at number 3. We got another list. So the x's are really the ones that are in charge. Okay? And I go through and I see a 2, a 3, a 2, and a 4. Uh-oh, I've got some x repeats. So is this a function? No, because x has a 5 and a 1. Okay? Okay. Oh, I shouldn't say x has a 5 and a 1. The 2. Okay? No, because 2 has a 5 and a 1 as an output. So 2 doesn't have its own y. 2 doesn't have its own y. There are x repeats. Okay, I'm trying to say it in a variety of different ways for you to be able to understand it. Okay, so now what if we have a graph? Okay, because down here we've got some graphs. So we have a special test called the vertical line test, and I like to call it the VLT for short. Okay, VLT, vertical line test. So that says if any vertical line passes through no more than 1 point of the graph of a relation, then the relation is a function. So what if we are given a graph? And this is a relation. I want to determine, is it a function? So we have this special test, the vertical line test. So if we take, and if we could draw any vertical line through our graph, think about vertical, okay, means that up and down, vertical line, and if it intersects the graph in more than one place, it's not a function. So in the second example, I have a horizontal line. Okay, I could draw a vertical line there, it's only going to touch it once. I could draw one over there, it's only going to touch it once. So if it passes that vertical line test, meaning that it only intersects it in one place, yes, it is a function. So when I look at this next example, if I chose to draw my vertical line there, I just found a vertical line that touches it in more than one place. That means that there were x's that repeated. So it's not a function. In other words, it failed the vertical line test. Okay. So let's go ahead and flip the page, and it says, high jumpers at a track meet were wearing numbers on their uniforms. Each of the 5 high jumpers on this team made 1 jump. The height cleared by each athlete is shown in the table. So we have our inputs are the athletes' numbers, and the outputs are the heights they jumped. Or in other words, those are my x's and those are my y's. Okay. It says use a mapping diagram. Okay, mapping diagram we had on the front. I explained what it was to show the athletes' numbers to their heights. So if I were to draw a map, okay, the mapping consists of 2 circles, and my x's are 1 through 5, and then my y's are my numbers, and they don't have to be put in order, okay, when you're putting them. As long as you get all of them in the other circle, you're fine. Okay, now 151 is twice, okay, but I only need to list it once. So 1 goes to 145, so I'm going to draw that mapping line. and then 2 to 143, and then 3 goes to 139, and 4 to 151, and 5 also to 151. Okay? Tell whether this relation is a function and explain why. Yes, because there are no x repeats. Okay, or in other words, in the context of this problem, there are no athlete numbers that repeat. Each x has its own y. Now it says, suppose the inputs are the heights cleared by the athletes and the outputs are the athletes' numbers. So in other words, we're switching the order. Okay, we're switching the order. So instead of me drawing this again, okay, well, I should draw it again. Never mind. I'll draw it again. Let's draw this. So they're switching the order, so saying that the heights that they cleared are the inputs, and their numbers, 1, 2, 3, 4, 5, are the outputs. So now let's see what happens. 143 and 2, and 139 and 3, and 151 and 4, and 151 and 5. That's the big no-no right there. Okay? We've got 151 that goes to 2 outputs. So is this relation a function? No. Okay? 151 repeated. Okay? To 4 and 5. Okay? And then the last one, it says a tank contains 8 gallons of water. Okay? Water is pumped into the tank at a rate of 2 gallons per minute. Okay, the total in the tank is Y. And the number of minutes is X. Write an algebraic equation. So if it says equation, it's got to have an equal sign for this function. So Y equals, it started with 8, and it adds 2 gallons every minute. You could also write it in mx plus b form. Now it says construct a table of x and y values for the function. So we're talking about time as my x's and gallons of water as my y's. So time can never be negative, so I'm not concerned with any negative x's. So I'm going to start off at time 0. And then I'm going to go up and I'm going to say 1, and then I'm going to do 2, and then I'm going to do 3 after 3 minutes. So at 0 minutes, how much water is in the tank? I should say 8, because it started out with 8. That's my starting point, my y-intercept. Now, after 1 minute, what do I have? I have 8 gallons plus 2 more, so that gives me 10. And then at 2 minutes, I had 8 gallons, but then I added 2 more, and then I had 2 more. So now I've got, whoops, I lied, 12 gallons. Okay. And then hopefully you're seeing this pattern here, 8, 10, 12. Okay. I should have 14 after 3 minutes. It says use this table of values to plot the graph to represent the function. So what I decided to do here, so my x is my time in minutes. And then up along the side is the gallons of water. Okay, it's my y. And I'm going to count by 2s, 2, 4, 6, 8, 10, 12, 14, up to 16. So we started out, my y-intercept is 0, 8. There's my starting point. And then after 1 minute, I have 10 gallons. At 2 minutes, I have 12 gallons. At 3 minutes, I have 14 gallons. I bet you could predict at 4 minutes, we're gonna have 16 gallons. You could continue on now that you're seeing that rate of change. Oops, a little clear about this. There's my function, okay? All right, see you guys in class.